Welcome to the deep dive. So you've brought us a whole bunch of material articles, forum chats, your own notes, all focused on this crypto called Kaspa. You probably heard the name, maybe seen the hype online, or this term BlockDAG keeps popping up. You're asking, what is it? Why should I care? What makes it tick? Okay, let's dive right in. We're going to unpack your sources, get to the heart of the tech, and see how Kaspa positions itself against the big names you know, Bitcoin, Ethereum, Cardano, all based on the stuff you gave us.
Exactly. The mission today is to understand what your sources say about Kaspa's tech, its claims, why people are excited, and the nuts and bolts, especially around mining it. We'll stick to the info provided.
Great. So let's start with the basics. What's the fundamental problem Kaspa is actually trying to solve here? What wasn't working with, say, Bitcoin?
Well, the sources really frame it around that classic blockchain challenge, the trilemma, right?
Yeah.
Balancing security, speed, and scale. Think about Bitcoin. It has that 10-minute block time. That wasn't an accident. It was designed for security, letting blocks propagate fully, minimizing those orphan blocks.
Orphan blocks? Those are valid blocks that just don't make it onto the main chain.
Exactly. But that 10-minute gap, while secure, really limits how many transactions can go through. The Bean Crypto source mentions about, 7 transactions per second for Bitcoin?
Yeah, only 7 TPS. And if you ever tried using Bitcoin when it's busy, yeah, you feel that. Slow confirmations, fees can shoot up, make small payments kind of impractical sometimes.
Precisely. That congestion, the slay speed as networks get popular, that's the issue Costas is targeting, according to these sources. The bottleneck is that linear, one block after another structure.
Okay, so if the single chain is the bottleneck, what's Kaspa's answer? This is the BlockDAG thing.
That's a core innovation, yeah. Instead of a linear blockchain, Kaspa uses a BlockDAG, a directed acyclic graph. Your sources use a good analogy. Think block web instead of blockchain.
A block web? Sounds potentially messy.
It's definitely a different structure. In a normal blockchain, each block points back to just one previous block. In a BlockDAG, blocks can reference multiple parents. Now, historically, that kind of web structure seemed problematic. Like, how do you get everyone to agree on the one true history? Old systems often just threw away blocks not on the longest or heaviest chain.
Right, the orphans we mentioned.
Yeah. But Kaspa's approach, using this BlockDAG, is designed to allow for parallel processing. Multiple sources like Ulam Labs and Bean Crypto point this out. Blocks can be created and confirmed, sort of, simultaneously.
Okay, hold on. Multiple blocks forming at the same time? How does that not just descend into chaos? How do you know which transaction came first if they're not in a neat line?
That's the crucial part. That's where the specific protocols come in, particularly Phantom and the star player, really, GHOSTDAG. They're both proof-of-work protocols, but built for this DAG structure.
Okay, tell me about those, Phantom and GHOSTDAG.
So Phantom is like the foundational layer, the proof-of-work protocol that actually operates on the DAG and allows those parallel blocks. Bean Crypto notes it helps sort out honest blocks, but GHOSTDAG, that's the really clever bit. Several sources call it the traffic controller. Its job is to take that complex web of blocks happening in parallel and impose a secure, agreed-upon order. Critically, it does this without throwing away valid blocks.
Wait, so it uses those blocks that would have been orphans in Bitcoin?
Exactly. That's a key point from Forbes and Ulam Labs. GHOSTDAG incorporates all valid blocks. Even if they were mined concurrently, they contribute their weight to the network's consensus and security. It solves this complex optimization problem, as Bean Crypto and Atomic Wallet put it, to establish that single, consistent order across the whole DAG.
That sounds really sophisticated. Does the GHOSTDAG name have roots in earlier crypto research? I feel like I've heard Ghost before.
It does. Jonathan Sompolinsky, who's central to Kaspa, also co-authored the original GHOSTDAG paper back in 2013, and, interestingly, invented Ethereum's early Ghost protocol. But there's an important clarification in one of the Reddit comments he provided. While related, GHOSTDAG isn't just the old Ethereum Ghost protocol slapped onto a DAG. It's better understood as a DAG-based variation of Bitcoin's consensus principles adapted for this parallel block structure.
Got it. So fundamentally different tech. BlockDAG structure, GHOSTDAG ordering it all. What does this actually mean for someone using Kaspa day to day? What are the results?
Well, the sources consistently point to 3 main advantages: speed, throughput, and cost. Because blocks can be processed in parallel, things are just much, much faster. Right now, the network's running at up to 10 blocks per second.
10 blocks per second? Compared to Bitcoin's 10 minutes per block. That's huge.
It's a massive difference. Forbes mentions this was actually an upgrade, part of the Crescendo hard fork, up from 1 block per second. And the Ulam Lab source says the goal is even higher. They're aiming for 32, maybe even 100 blocks per second down the line.
Wow. Okay, so that speed must mean it can handle way more transactions too.
Exactly. Higher block rate equals higher transaction throughput. Sources mention tests hitting around 4,000 transactions per second. Again, compare that to Bitcoin's single digits.
And finality. How quickly can you be sure your transaction is confirmed and irreversible?
The atomic wallet source talks about near instant finality, achieving practical confirmation within seconds. Now, pinning down the exact number of confirmations needed for absolute certainty in a fast DAG is complex, as a Reddit thread discusses. Someone there estimated maybe 50 confirmations for high-value stuff, 10 for low value with 10-second blocks, but admitted it gets tricky to calculate precisely with even faster blocks, like 10 per second. And they noted, along with Atomic Wallet, that documentation on finality specifics isn't fully fleshed out yet. But for everyday use, the claim is seconds.
Okay, speed and throughput are clear wins. What about the cost? Do fees go down with all this capacity?
That's the other big one. The sources are pretty unanimous here. Because of the high capacity and parallel processing, transaction fees are incredibly low. Practically free, some say. That opens up possibilities for things like micropayments that just aren't feasible on more expensive chains.
Right, that definitely tackles some of the major complaints about older cryptos.
Yeah.
So let's put it head-to-head. How does Kaspa stack up against Bitcoin, Ethereum, Cardano, based on what your sources say?
Okay, let's break down those comparisons from the material. Versus Bitcoin, Kaspa is also proof of work, aiming for that same kind of security model. One source even says similar security to Bitcoin's heaviest weight. But it's positioned as a significant upgrade. A much better version of Bitcoin is phrasing used, aiming to overcome Bitcoin's single-chain limitations for way faster speed, lower fees, and more transactions. That's a common thread in Forbes, Atomic Wallet, and the Reddit discussions.
Okay, so pals of you like Bitcoin, but faster. What about compared to smart contract platforms like Ethereum or Cardano?
That's a key difference. The sources make it clear Kaspa currently uses a UTXO model, like Bitcoin, for handling transactions. And crucially, it does not have native smart contract capabilities on its main layer. It's layer 1.
So no DeFi, no complex dApps running directly on Kaspa itself right now.
Not natively on layer 1, no. According to the roadmap sources, adding smart contracts is a future goal. But there's debate in the Reddit threads you shared about how complex that will be, whether it's adding a layer or needs a deeper rewrite of the core code given the UTXO base. It's worth mentioning layer 2 solutions are being explored on top of Kaspa. BitsLab research talks about something called Kasplex L2, suggesting Kaspa's L1 might be a flexible base for these. And there's mention of a KRC20 token standard, but sources stress it's like Bitcoin's BRC20 using JSON data, not like Ethereum's smart contract ERC20s.
That's a really important distinction. And the core consensus mechanism, Kaspa's proof of work, while Ethereum's now mostly proof of stake, and Cardano is POS2.
Correct. And your sources dip into that whole POW versus POS debate. We should just report the arguments presented. For POW, the security argument relies on the real-world cost of energy needed to attack. For POS, it's about locking up the network's own token. Attacking hurts your own investment.
Any arguments about decentralization?
Yeah, one viewpoint in the Reddit thread suggests POW might be more accessible because anyone can theoretically get electricity, while getting enough coins for significant POS influence might be harder, potentially centralizing power. The counterargument presented there is that attacking POS means buying tons of tokens, driving up the price, making it prohibitively expensive and self-defeating for the attacker. The discussion also touches on risks like mining or staking pools concentrating power, and mentions specific attacks like selfish mining, though clarifies what that actually entails. Interestingly, one comment flags accidental client bugs as a potentially bigger risk in complex POS systems, just due to the sheer complexity. So yeah, different viewpoints on security and risk.
Okay, definitely a nuanced debate there. Shifting gears to mining Kaspa itself. You mentioned it's proof of work. What kind of gear do you need? Is it another Bitcoin situation where only people with specialized hardware, the ASICs, can really make money?
Right. The mining algorithm is called Heavy Hash. Ulam Labs and Forbes mentioned this. The original intent for KV Hash was efficiency and broad hardware support. So yes, the sources confirm it was designed to work well with GPU mining using regular graphics cards.
Ah, so initially more accessible.
That seems to have been the goal. However, the Atomic Wallet source explicitly states that while it started GPU-focused for decentralization, specialized ASIC miners for Kaspa have been developed and are out there now.
Okay, so ASICs are involved, like Bitcoin. Does that mean small miners are pushed out again?
Well, this is where Kaspa's design tries to be different. According to BN Crypto and Atomic Wallet, that super high block rate 10 per second currently changes the game. Because blocks are found so frequently, even miners with relatively low hash power have a statistically much better chance of finding a block fairly regularly compared to a slow chain like Bitcoin. This makes solo mining potentially viable even without massive hardware investment, unlike Bitcoin, where small miners almost have to join pools to get consistent rewards, as that Reddit thread points out. So ASICs exist, yes, but the high block frequency is intended to keep mining more decentralized.
That's a really interesting dynamic. Okay, so pulling it all together, the unique tech, the speed, the low fees, this mining approach, all the hype, what's driving the buzz around Casper right now?
Based on your sources, it seems to be a mix of the technical ambition actually delivering results, plus the project's philosophy. Trying to crack the scalability problem within proof of work using the BlockDAG is seen as genuinely innovative. And it's not just theory. The fact it's already doing 10 blocks per second with tiny fees and fast practical finality while sticking to POW security principles, that's a compelling story. It works.
Performance matters, definitely.
Absolutely. And then there's the origin story. Forbes and Atomic Wallet highlight the fair launch, no pre-mine, no ICO, very community-focused. That appeals to people who liked Bitcoin's original ethos. Combine that with a growing community and ecosystem, plus getting listed on more exchanges, as Ulam Labs notes, and you get momentum. The Reddit price discussion shows people are definitely watching things like potential Tier 1 exchange listings.
So tech promise meets real performance meets community appeal. Makes sense. What about the future? What's on the roadmap and what challenges do the sources say Kaspa still needs to overcome?
Key roadmap items include, first, that smart contract implementation. It's listed as planning by Kaspa Developments and Wooly Pooly. We talked about the potential complexity there, but it's a major goal for enabling DeFi and dApps. Second, a big technical upgrade called DAGKNIGHT. It's in development and described as the next step beyond GHOSTDAG, aiming for things like faster responsiveness, maybe even 50% fault tolerance, using a dynamic K-value that adapts.
Okay, sounds ambitious. Anything else?
Yeah, user-facing stuff too. A mobile wallet is listed as in development or perhaps recently completed, and ongoing work to integrate with hardware wallets like Ledger for better security, mentioned by Wooly Pooly.
And the hurdles. What are the challenges mentioned?
Well, the DAG structure itself is complex. There are practical things, like needing significant storage space for the blockchain data, although the Reddit source mentions pruning as a way to manage that. Documentation is another area highlighted, needing more comprehensive technical docs and better Block Explorer tools to help developers and users navigate everything. And obviously, successfully implementing smart contracts is a big technical lift. Forbes also adds a note of caution. While the speed is impressive, the network's behavior under really heavy, sustained load or under-sophisticated attack at these sub-second block speeds is less battle-tested than older, slower chains.
Right, the real-world stress testing is still ongoing in some ways. Yeah. Okay, that gives us a really solid picture of Kaspa's tech, its goals, and where it stands.
Definitely. It's a clear attempt to push proof of work into territory usually associated with proof of stake or layer 2s, doing it by fundamentally changing the structure from a chain to a DAG.
So for you, listening in, having provided these sources, you've now got a much deeper understanding. You see the problem, Kaspa targets, speed scale.
Yeah.
The core tech, BlockDAG, GHOSTDAG. The benefits, speed, low fees. How it differs from Bitcoin, faster POW. And Ethereum Cardano, no native smart contracts yet, POW versus POS. And the mining situation, GPU ASIC mix, but maybe better solo viability.
Exactly. We've covered the innovation claims, the performance, the comparisons, the mining details, the future plans, and the challenges, all based on the material provided. Which leaves us with a final thought to chew on, directly from exploring this material. Kaspa has this ambitious technical vision, DAGKNIGHT, smart contracts. Can it actually scale this complex BlockDAG structure and achieve its goal of being the fastest, most scalable, and secure Layer 1 proof-of-work crypto? Or will the very complexity of managing that block web eventually introduce new kinds of trade-offs or limitations that simpler chains don't face? It's certainly something to watch as the project develops.